Janice?
I don't think so. But
Oh, okay. You can check the video later.
Okay.
At least, we can reach the expression. This one. And this expression, in fact, we use mu. Right? Previously, we derived for this inequality. And this inequality, actually, it's the confidence interval here. So confidence interval, in fact, it should be this one. It's sample mean. And we have the interval. And this one, it should be S bar plus Z, square root. And this one, it should be S bar minus Z. So here, if we want to have a plot, a bar, actually it should be sample mean, and sample mean a bit higher, and sample mean a bit lower. So a bit higher, how to have the manipulation? Z multiplies square root of x squared over n. That's it. Well, understand confidence interval specified here totally by checking the derivation using central limit theorem to have the approximation of standard normal. Right? Again, let me make sure that understand and Ari and Alan and Jerry, Robin. And Candice, up to now, understand what I'm talking. Okay, maybe no, but you check it later.
Okay.
So this is first expression, standard normal, with a given parameter z, but z should be found through standard normal. Well, this is standard normal, and then we have another distribution first, and later we can know the same story using this figure. In fact, we can have a new distribution. This distribution called T distribution. T distribution actually a bit flatter. 有一个 T 分布是更为平坦一点。So a bit flatter T distribution. Why I mentioned a bit flatter T distribution? T distribution is another type of distribution, another type of PDF. Again, symmetric PDF. Well, if T, why we should employ T? If we have a T, then Z will be replaced by T. So okay to have a T, okay to have T. All right, so this is a story we need to use. Well, that's it, T distribution. Why we want to have a T distribution? This one. The second one, someone let you know later. Well, approximation by CLT, not okay at all. Not okay at all. Actually, it's not. So why not okay at all? If we have IID observation and furthermore assume they are normal random variables. Right? Assume they are normal random variable. Then previously we have this one, and this one this time we have the new notation T. And then we have the fact. It follows T distribution. And T distribution with the specified degree of freedom. It's n minus 1. So the exact confidence interval should follow T, but not Z. Right? For this reason, we can have a T rather than Z. That's it. However, we have the range applicable to normal observations. If we have normal observations, then we can use T distribution. With the T distribution, then we can have the new confidence interval. Replace Z by T. But T, we have a degree of freedom, so that's why we have a parameter put into this position. So originally probability is 1 minus alpha over 2, the same because of symmetry. However, we have a new parameter, degree of freedom, n minus 1. So here we have n minus 1 associated with the parameter t. However, you can check the second term. In practice, xi actually will already be normal. So of course, the previous one still an approximation. However, at least if we have the special case, talking about normal random variable, actually we can have the exact confidence interval. So which one will be the suitable one? Normally, if we can apply t distribution, then we choose t distribution. If never mind that one, you can use z. So t or z, either one will be okay. However, if you ask me which one will be the best one, I ask you to use t. Is it okay? Why? Because of exactness, even finally is still a approximate solution, but t will be the better one. If we have a t, let me ask you the question. If we have here, if we have standard normal, and also we have a t distribution, if we use t or z given, for example, 90%, which interval will be wider? T to have a wider interval, or z that says normal to have a wider interval. If we have the same confidence probability, 90%. Again, you can talk to the person next to you. Just 10 seconds. 10 seconds. And then we have the result later by checking one, maybe example of result 1 or result 2. If you check the current figure here, which one provides a wider confidence interval, t or normal？ 我要问的问题是 t 分布得到的 confidence interval 比较宽，还是 normal 分布得到的 confidence interval 比较宽？假设我给定的 probability 是一定的，例如说固定是 90%。So this is a question. Okay, that's it. So right now, each of you let me know your status. If you think T provides the wider confidence interval, raise your hands. T distribution. T distribution, maybe okay, more than a half. Normal distribution, no one. Yeah, that's correct. T, because we have the same probability. So you see, T a bit flatter. So of course we need to cover the same probability. So of course T to have a wider one for T. So this is another reason. T actually covers a wider interval. So that says it will be self. You understand? T to cover a wider, it will be a self same, using the sense of a self. A wider one will be better. So that's why we prefer T using this one. So I skip the same reason to derive T because the same procedure, but replace Z by T. That's it. So this is the confidence interval if we want to use T.